Welcome. Today we're diving into the fascinating world of machine language, the most fundamental language that computers understand. Before we get into the details, let's set the stage. Every computer, from your smartphone to the world's fastest supercomputer, relies on machine language to function. This language is made up of binary code, just ones and zeros. But why is this important? Well, without machine language, computers wouldn't be able to process any instructions or perform any tasks. In this video, we'll explore what machine language is, how it works, and why it's so crucial for computing. Let's get started by understanding the basics. Machine language is the lowest level programming language, consisting entirely of binary digits, ones and zeros. These binary instructions are directly executed by a computer's central processing unit, or CPU. Unlike high-level languages like Python or Java, machine language is not meant for humans to read or write easily. Instead, it's designed for machines, allowing them to perform operations like arithmetic, data movement, and logical decision. Every instruction in machine language tells the computer exactly what to do, step by step, with no room for ambiguity. This precision is what makes computers so powerful and reliable. Let's break down binary code. At its core, binary code uses only two symbols, 0 and 1. Each digit is called a bit, and a group of 8 bits forms a byte. Computers use these bits to represent everything: numbers, letters, images, and even sounds. For example, the letter A in binary is 1,000,001. By combining different patterns of zeros and ones, computers can store and process all kinds of information. Understanding binary is key to understanding how machine language works, as every instruction and piece of data is ultimately represented in this simple, yet powerful format. Central Processing Unit, or CPU, is the brain of the computer. It's responsible for executing machine language instructions. When you run a program, the CPU reads the binary instructions from memory and carries them out one by one. Each CPU has its own set of instructions, known as the instruction set architecture, or ISA. This means that machine language can vary between different types of CPUs. However, the basic principle remains the same. The CPU fetches, decodes, and executes instructions, allowing your computer to perform tasks quickly and efficiently. Instruction set architecture, or ISA, defines the set of machine language instructions that a CPU can execute. Think of it as the vocabulary of the CPU. Different CPUs like Intel and ARM have different ISAs, which means their machine languages are not always compatible. The ISA specifies how instructions are formatted, what operations are available, and how data is accessed. This is why software compiled for one type of CPU might not work on another without modification. Understanding ISA is essential for anyone interested in how computers process information at the lowest level. Each machine language instruction tells the CPU to perform a specific operation. For example, an instruction might tell the CPU to add two numbers, move data from one place to another, or compare values. These instructions are made up of an operation code or opcode and sometimes additional information like which data to use. The CPU reads the opcode, figures out what action to take, and then executes it. This process happens millions or even billions of times per second, allowing computers to perform complex tasks with incredible speed. Let's look at some simple examples of machine language instructions. An instruction might look like 10,110,000, which could mean load a value into a register. Another might be 11,011,011, meaning add two numbers together. Each instruction is just a pattern of bits, but to the CPU, these patterns are clear commands. While these codes look meaningless to us, they are the building blocks of every program and process running on your computer. By combining thousands or millions of these instructions, computers can perform everything from simple calculations to running complex applications. You might have heard of assembly language, which is closely related to machine language. Assembly language uses short, human-readable codes called mnemonics, like MOV or ADD, instead of binary numbers. These mnemonics are then translated into machine language by a program called an assembler. While assembly is easier for humans to read and write, it still maps directly to machine instructions. This makes it a powerful tool for programmers who need to write very efficient or hardware-specific code. Writing programs directly in machine language is extremely difficult and time-consuming. Since it's just a long string of ones and zeros, it's easy to make mistakes and hard to understand what the code does. That's why most programmers use higher-level languages like Python, Java, or C++. These languages are much easier to read and write, and they get translated into machine language by compilers or interpreters. This way, humans can focus on solving problems while the computer handles the details of machine code. You write a program in a high-level language, it doesn't run directly on the CPU. Instead, a special program called a compiler or interpreter translates your code into machine language. The compiler checks your code for errors, optimizes it, and then generates the binary instructions the CPU can execute. This process allows programmers to write complex software without worrying about the details of machine language, while still taking advantage of the computer's speed and power. Operating systems like Windows, macOS, or Linux play a crucial role in managing machine language instructions. They act as a bridge between your applications and the hardware, making sure that programs get the resources they need and that instructions are executed safely and efficiently. The operating system translates high-level requests, like opening a file or connecting to the internet, into machine language instructions that the CPU can understand. This makes it possible for users to interact with computers without needing to know anything about machine code. Machine language isn't just for desktop computers. It's used in all kinds of devices, from smartphones and tablets to smart TVs, cars, and even household appliances. Any device with a microprocessor relies on machine language to function. Whether you're sending a text message, streaming a movie, or adjusting your thermostat, machine language is working behind the scenes to make it happen. This universality is what makes machine language so important in our modern, connected world. Machine language has evolved alongside computer hardware. Early computers had very simple instruction sets and could only perform basic tasks. As technology advanced, CPUs became more powerful and instruction sets grew more complex, allowing computers to handle more sophisticated operations. Today's CPUs can execute billions of instructions per second and support advanced features like parallel processing and virtualization. Despite these advances, the core idea of machine language communicating directly with hardware remains unchanged. One of the main reasons machine language is so important is performance. Because machine language instructions are executed directly by the CPU, they run as fast as possible. High-performance applications like video games or scientific simulations often rely on carefully optimized machine code to get the best speed. Even small improvements in machine language can lead to big gains in performance, making it a key area for computer engineers and programmers who want to push hardware to its limits. Security is another area where machine language plays a vital role. Because machine language controls the hardware directly, vulnerabilities in machine code can lead to serious security risks. Hackers sometimes exploit flaws in machine instructions to gain unauthorized access or control over a system. That's why operating systems and security software pay close attention to how machine language is used, ensuring that only safe and authorized instructions are executed. Debugging machine language is a challenging task. Since the code is just a series of ones and zeros, finding and fixing errors requires specialized tools and a deep understanding of how the CPU works. Programmers use debuggers and emulators to step through machine instructions, examine memory, and track down bugs. This process can be time-consuming, but it's essential for creating reliable and efficient software, especially in critical systems like medical devices or aerospace technology. Embedded systems are specialized computers built into devices like cars, washing machines, and industrial robots. These systems often use machine language to control hardware directly, ensuring fast and reliable operation. Because embedded systems have limited resources, machine language allows programmers to write highly efficient code that makes the most of the available memory and processing power. This is why machine language remains a critical skill in fields like automotive engineering and industrial automation. Microcontrollers are tiny computers found in everything from toys to medical devices. They run simple programs written in machine language to control sensors, motors, and other hardware. Because microcontrollers often operate in real-time environments, machine language ensures that instructions are executed quickly and predictably. This reliability is essential for applications where timing and precision are critical, such as in pacemakers or automotive safety systems. Working hardware, like routers and switches, also relies on machine language. These devices process data packets at high speed, using machine instructions to route information efficiently across the internet. By using machine language, networking equipment can handle vast amounts of data with minimal delay, ensuring fast and reliable communication between devices. This is a key reason why the internet is able to support billions of users worldwide. Graphics processing units, or GPUs, use machine language to render images, videos, and animations. GPUs are designed to execute many instructions in parallel, making them ideal for tasks like gaming, video editing, and scientific visualization. Machine language allows GPUs to perform complex calculations quickly, delivering smooth graphics and realistic effects. This technology is also used in artificial intelligence and machine learning, where massive amounts of data need to be processed rapidly. Storage devices, such as hard drives and solid-state drives, use machine language to manage data. When you save a file, the storage controller translates your request into machine instructions that read, write, or erase data on the physical media. This process happens in microseconds, ensuring that your data is stored and retrieved quickly and accurately. Machine language makes it possible for storage devices to handle large volumes of information efficiently. Cloud computing relies on vast networks of servers, all running machine language instructions to process data and deliver services over the internet. Whether you're streaming music, backing up photos, or running business applications, machine language is working behind the scenes to make it possible. The efficiency and speed of machine language allow cloud providers to serve millions of users simultaneously, making modern digital life possible. Artificial intelligence systems, like those used in voice assistants or self-driving cars, depend on machine language to process vast amounts of data in real time. Machine instructions enable AI algorithms to analyze images, recognize speech, and make decisions quickly. By optimizing machine code, engineers can improve the speed and accuracy of AI systems, making them more responsive and effective in everyday applications. Robots use machine language to control their movements, sense their environment, and interact with objects. Each action from moving an arm to picking up an object is broken down into a series of machine instructions. By programming robots at the machine language level, engineers can achieve precise control and fast response times, which are essential for tasks like manufacturing, surgery, or space exploration. Supercomputers used in scientific research rely on machine language to perform complex calculations, simulate physical processes, and analyze massive datasets. Machine instructions allow these powerful machines to solve problems in physics, chemistry, biology, and more. By optimizing code at the machine language level, researchers can achieve breakthroughs in areas like climate modeling, drug discovery, and space exploration. Financial systems, such as stock exchanges and banking networks, use machine language to process transactions at lightning speed. Every time you swipe a credit card or make an online payment, machine instructions are executed to verify your identity, transfer funds, and update records. The speed and reliability of machine language are critical for maintaining trust and security in the global financial system. Healthcare devices like MRI machines and patient monitors use machine language to collect and process medical data. These devices must operate with high precision and reliability, as they are often used in life-critical situations. Machine language ensures that instructions are executed quickly and accurately, enabling doctors and nurses to make informed decisions and provide better care for patients. Modern cars are packed with computers that use machine language to control everything from engine performance to safety features like airbags and anti-lock brakes. These systems must respond instantly to changing conditions, making machine language the ideal choice for real-time control. By optimizing machine code, automotive engineers can improve fuel efficiency, reduce emissions, and enhance safety. Entertainment devices like gaming consoles and smart TVs use machine language to deliver fast, immersive experiences. Machine instructions control everything from graphics rendering to audio playback, ensuring smooth performance and high-quality visuals. By writing efficient machine code, developers can create games and applications that push the limits of what hardware can do. Aviation systems, including flight control computers and navigation equipment, rely on machine language for safety and reliability. These systems must process data from sensors, make real-time decisions, and control aircraft systems with absolute precision. Machine language allows engineers to write code that meets the strict requirements of the aviation industry, ensuring safe and efficient flights. Spacecraft and satellites use machine language to control navigation, communication, and scientific instruments. In the harsh environment of space, reliability is critical. Machine language allows engineers to write code that operates efficiently and withstands the challenges of space travel. From landing rovers on Mars to transmitting data across millions of miles, machine language is at the heart of every space mission. Energy systems such as power plants and smart grids use machine language to monitor and control equipment. Machine instructions manage everything from electricity generation to distribution, ensuring that power is delivered safely and efficiently. By optimizing machine code, engineers can improve the reliability and sustainability of energy systems, supporting the transition to renewable energy sources. Modern agriculture relies on computers and sensors to monitor crops, control irrigation, and manage equipment. Machine language enables these systems to process data in real time, making farming more efficient and sustainable. By using machine instructions, agricultural technology can respond quickly to changing conditions, helping farmers increase yields and reduce waste. Educational technology like interactive whiteboards and learning apps uses machine language to deliver engaging and personalized experiences. Machine instructions control everything from touch input to multimedia playback, making learning more interactive and effective. By optimizing machine code, developers can create educational tools that are fast, reliable, and accessible to students around the world. Communication devices like smartphones and video conferencing systems use machine language to process audio, video, and data in real time. Machine instructions enable fast, reliable connections, making it possible to stay in touch with friends, family, and colleagues anywhere in the world. By optimizing machine code, engineers can improve call quality, reduce latency, and support new features. Security systems like surveillance cameras and alarm systems use machine language to detect threats and respond quickly. Machine instructions control everything from motion detection to video recording, ensuring that security devices operate reliably and efficiently. By writing efficient machine code, developers can create systems that protect homes, businesses, and public spaces. Logistics companies use computers to track shipments, manage inventory, and optimize delivery routes. Machine language enables these systems to process large amounts of data quickly, ensuring that goods are delivered on time and at the lowest cost. By optimizing machine code, logistics providers can improve efficiency and customer satisfaction. Manufacturing plants use machine language to control robots, assembly lines, and quality control systems. Machine instructions ensure that products are made accurately and efficiently, reducing waste and improving quality. By optimizing machine code, manufacturers can increase productivity and stay competitive in the global market. Smart home devices like thermostats, lights, and security cameras use machine language to automate tasks and respond to user commands. Machine instructions enable these devices to operate efficiently and interact with other smart devices, creating a seamless and convenient living environment. By optimizing machine code, developers can improve the performance and reliability of smart home technology. Wearable devices like fitness trackers and smartwatches use machine language to monitor health data, track activity, and provide notifications. Machine instructions ensure that these devices operate efficiently, with long battery life and accurate measurements. By optimizing machine code, developers can create wearables that are both powerful and user-friendly. Environmental monitoring systems use sensors and computers to track air quality, water levels, and weather conditions. Machine language enables these systems to process data in real time, providing valuable information for scientists, governments, and the public. By optimizing machine code, engineers can create monitoring systems that are accurate, reliable, and energy efficient. Public transportation systems like trains and buses use computers to manage schedules, track vehicles, and process payments. Machine language enables these systems to operate efficiently and respond to changing conditions, ensuring that passengers get where they need to go safely and on time. By optimizing machine code, transit agencies can improve service and reduce costs. Retail systems like point-of-sale terminals and inventory management software use machine language to process transactions and track products. Machine instructions ensure that sales are recorded accurately and inventory is updated in real time. By optimizing machine code, retailers can improve efficiency, reduce errors, and provide better service to customers. Research and development teams use computers to design new products, simulate processes, and analyze data. Machine language enables these systems to perform complex calculations and process large datasets quickly. By optimizing machine code, researchers can accelerate innovation and bring new ideas to market faster. Summary: machine language is the foundation of all computing. It enables computers to execute instructions quickly, reliably, and efficiently, powering everything from smartphones to supercomputers. While most people never see machine language directly, its impact is everywhere in modern life. By understanding how machine language works, we gain a deeper appreciation for the technology that shapes our world. Thanks for joining us on this journey through the basics and applications of machine language in computers.